I'm going to take you on a sort of a little journey here where we're going to follow this example through to its conclusion, and then hopefully you'll be able to identify an interesting pattern that'll help you, I think, when you're dealing with complex numbers later. So we're given two complex numbers. Often they're written as with the letter z. X often, x is the variable we use for real numbers, and z often for complex numbers. And the subscripts 1 and 2 just identify that they're two different complex numbers. So z1 is 1 plus 4i, and z2 is negative 2 minus 2i. And so we're asked to plot them on the plane to the right, and then compute their absolute values. So let's do that. z1 would be 1 plus 4i, so I go right 1 and up 4, so I'm here. Okay, and so that's z1. And z2 is negative 2 minus 2i, so let's left 2 down 2. And so there's z2. And so now to find the absolute value of z1, well, we make our good old right triangle. It's not the best right triangle, but hopefully yours is better. Right? We know that's a 1, that's a 4, and so our r here, or our hypotenuse, I guess I can call it r, it would be so that would be r squared, and I can just use the Pythagorean theorem. So that's 1 squared plus 4 squared. And so that means that if I square root, that means that I might as well square root this too. That means that r, or the absolute value of z1, is equal to the square root of 17. And so we'll circle that. And to calculate z2, so that's a negative 2 and that's a positive 2, so we want r, and again we can use the Pythagorean theorem. So this time we get square root or equal to 2 squared plus negative 2 squared. Which gives me 8. So if I square root, I get that r is 8. Or square root of 8, rather. There we go. So there's their magnitudes. Now we have to compute their angles. So I'm going to redraw them here. This is z1 again, 1 plus 4i is here. And so if I draw that triangle there, I'm interested in this angle right here, theta, call that theta. And so I can get that pretty easily, right? So for z1, I know that the tangent of the angle is equal to 4 over 1. And so therefore our angle is equal to tan inverse of 4 over 1. And that turns out to be, when I put in the calculator, 75.96 degrees. And for Z2, we actually don't need to do any work because, so there's Z2. We don't really need to do any work because, I mean, there's the angle we're sort of interested in, or at least in the immediate future we're interested in. So for Z2, right, the tangent of the angle is equal to -2. Oops, I forgot to label these negatives. It doesn't affect the final answers over here, but still, technically I should have put that negative there. But in any event, the tangent of the angle is equal to -2 over -2. Tangent of the angle is equal to 1. And whether you do tan inverse or not, you get that our angle is 45 degrees. You could have also just noted it's a right triangle with, or it's a right isosceles triangle. But that's actually not the angle we want, is it? Right? As usual, we want this angle here. And that angle, for that angle, we'd have to add 180 degrees to bring us to 225 degrees. All right. So we've got our angles. We've got our angles, and we have our magnitudes there. And so I'm going to stop here, and in the next video you'll see where we're going with this. We'll do another problem using using this information as well. So stay tuned.